Hello from ChemHelp ASAP. In this video we will discuss how to quickly determine the number of valence electrons you have in a particular element using the periodic table. Now on the screen we have a periodic table, and this is even an abbreviated periodic table, and yet there are still a lot of elements here. Our task as organic chemists is made simpler by the fact that we will typically only encounter about 10 elements in performing organic reactions. And those elements are as follows. I'll circle them as we go through them. Atomic number 1, in the first period, hydrogen. In the second period, we will often encounter carbon, nitrogen, oxygen, and fluorine. In the third period, just below, we have phosphorus, sulfur, and chlorine. And in periods 4 and 5, we have bromine and iodine. So these are the 10 common elements we will encounter. And if you notice, these are all considered main group elements. They're all pulled from the main groups. So these groups, which represent the columns on the periodic table, are labeled with, in this case, Roman numerals. So this is a Roman numeral 1, Roman numeral 2, and that Roman numeral actually represents how many valence electrons that element has. So hydrogen is in group 1. It has one valence electron. Carbon is in group 4. It has 4 valence electrons. Fluorine, chlorine, bromine, and iodine are in group 7. They have 7 valence electrons. So this is a really simple way to use a periodic table to know how many valence electrons you have. A word of warning: newer periodic tables will not be numbered in this fashion for their groups. They will be numbered consecutively 1 through 17. So I'm going to the bottom of the screen. This will be in Arabic numbers, not Roman numerals. 1, 2, 3. And let's go across the D block, skip those. 13, 14, 15, 16, 17, and 18. Okay, well, carbon, formerly in group 4, clearly at the bottom of the screen does not have 14 electrons. What you can do is just chop off the tens place. So 14, it's not 14, it's 4. Carbon has 4 electrons. Fluorine, atomic number 9, doesn't have 17 electrons, it has 7 electrons. Take off the tens place. So we can still use these new group numbers to determine quickly how many valence electrons we have. This is a really easy shortcut. As you work with elements over time in organic chemistry, you're not going to need the periodic table to know your valence electrons. You're going to simply be so familiar with them, you'll have them memorized. But in the meantime, the periodic table does offer a lot of help for determining the number of valence electrons for each of our commonly encountered elements.